So, hello everyone, I'm Dr. Shruti Pandey from University of Louisville. So, we have already taken a question from Thevenin's theorem, and this is an example for Norton's theorem. So, here what is asked in the question, find I or the current through 6 ohm using Norton's theorem. So, you need to find this current. Okay, so whenever you want to find or whenever you see a Norton theorem question where you need to find a resistance through a particular a current through a particular resistance, there are two things. The first thing is find ISC, that is short circuit current, and second step is find IRN. And this Norton resistance or RN, we also call it as RTH, because this is the same resistance which we have considered while analyzing the Thevenin's theorem. So these two are exactly the same and they are analyzed in exactly the same way. Okay, so what do you need to do while analyzing ISC? You need to you need to short circuit that branch or that resistor where you need to find current, right? So in this case you need to find current in this branch, that is 6 ohm resistance. So you are going to short circuit 6 ohm resistance and then you will find I through it, right? And that to that I we'll call it as ISC. Okay, so let's start it. So first step, we'll find ISC. This is step 1. Right, so to find ISC, I told you short circuit this 6 ohm branch. And how will the circuit look like? Circuit will look like this. This is 12 ampere. This is 8 ohm. This is 4 ohm. One thing which you can do here before short circuiting this branch is you can just add these two resistances as they are connected in series. You can see that whatever current is going here, the same current is going here also, and their one terminal is connected to each other. The other terminals are open, right? They are not connected to each other. They are not open, but they are not connected to each other. And this is how two resistance in series look like. Their one terminal is connected, the other two are not connected to each other. Therefore, the send 10 and 2, these two resistances are connected in series, and in series we can directly add the resistances and make it 12, right? So maybe we can directly add it here and it will be 12 ohm, and this is that short circuit branch. We have short circuited that 6 ohm and we are going to find the value of I here, and that I will call it as ISC. Okay, so okay, now one more important concept. You know that this all is ground. This all is ground. By that I mean the voltage or potential here is 0. Okay, everywhere in the ground it is 0. So if the voltage here at this point is 0, the potential or the voltage at this point will also be 0, right? Why so? Because if this is 0 and there is certain resistance here R1, and the voltage drop across that resistance, that is V1, is I into R1. If there is no R resistance here, that means this is 0, right? And that means voltage drop is 0. So therefore whatever was the voltage here, as V1 is 0, or you can say there is no voltage drop here, here also the voltage will be equal to 0. Okay, so here the voltage is 0. This is a short circuit branch, that means this is also 0. One more thing, you know, this is that the voltages in parallel branches are same. So therefore voltage across this 12 ohm will also be 0. You know this, right? If there are two resistances connected in series, then the current is same, right? So whatever current is coming from here, this current will be same. The same current will be flowing from R1 and the same current will be flowing from R2 and so on, right? Similarly, the voltages in parallel is same, right? Here whatever current is coming from here, in parallel the current gets divided, or you can say that in parallel, the current in parallel resistor branches, the current is not same, rather it is different, and voltages are same. So if this is V volt, the voltage here will also be V volt, and the voltage here will also be V volt, until unless there is any resistance here in between, or there is an additional voltage drop here. That in that situation, here the voltage can differ, right? So therefore we can conclude this, from this point we can conclude this, that the voltages in both these branches, I'll just rub this all to make it neat and clear. So if the voltage in this branch is 0, the voltage across this branch will also be 0, and the circuit will look somehow like this. So it is 12 ampere, and this is 8 ohm, this is 4 ohm, and this is short circuit branch, and here you need to find the value of that current, which is ISC. So what all are the ways you can apply KCL here, Kirchhoff's current law or nodal. So mark this voltage as V1 and see the outgoing currents and all. So this is an incoming current here, we can mark these current as outgoing current. So KCL will be 12 is equal to sum of incoming current is equal to sum of outgoing current. So let us call this current as I1, and this is already given ISC. So 12 will be equal to I1 plus ISC, where the value of I1 will be V1 minus 0 by 8, because this is this current and this all is 0, right? So an ISC will be V1 minus 0 by 4 is equal to 12. So I'll just go down. So it will be 12 is equal to, this is 8, this is V1 plus 2V1. So that is 12 into 8 by 3 is equal to V1. So this is 32 volt, right? The value of V1 is 32 volt. And what do you need to find? You need to find the value of this current ISC. So V1 is, so from here, this ISC is this. So from here you can find ISC is equal to V1 minus 0 by 4. That is 32 by 4. And that way we get ISC current as 8 ampere, right? So the value of ISC is 8 ampere. So we have found this ISC thing. Now we need to find out the value of this RTH or RN. So I told you, you need to calculate the Norton equivalent resistance, which is RN, exactly in the same way you have calculated RTH before. So what all do you do while calculating RTH? So step 2 is calculate RN. We can also call it as RTH. So what are the steps for that? Short circuit all voltage sources and open circuit all current sources, right? And before this, what do you need to do? Open circuit the resistor branch where you need to find the value of current. So that branch is 6 ohm, right? So see how the circuit will look like. I'll just minimize it so that I can make the circuit easily. So how will the circuit look like? This is a current source, this will be open circuit. So this 12 volt is open circuit, this 08 ohm will be there, this 4 ohm will be there. Across the 6 ohm, in this question this was, here you need to find out the value of RTH. So the 6 ohm, you are going to take this out, right? You'll open it, and there you will keep this RTH. That we need to find the value of resistance here. Then what's the next resistance in the circuit? So it's 10 ohm and 2 ohm. Okay, so this is 10 ohm and this is 2 ohm, which we can see easily that they are connected in series. So we'll redraw this circuit again. This circuit, we'll redraw it. So open circuit do not have any significance, therefore this part is out. Then this is 4 ohm, then this 10 plus 2, they are connected in series. So we can take it as 12 ohm, right? 12 ohm, and this point is RTH, right? We can simplify it as like here these two are connected in series because same current is going. So 8, 9, 10, 11, 12. So it is like this RTH here, here it is 12 ohm, and here also at this side also it is 12 ohm, right? So let's call these terminal as A and B. So how can we see these terminals as, like, this is A, this is B, this is this 12 ohm, right? And this 12 ohm is also connected between these 2 points A and B. So you can see it like this, right? To see it whether they are parallel and series. So you can see that this 12 ohm is also connected in these points A and B. So now you can see that these two are parallel, right? So this is RTH. I'll not write this plus here. So this is RTH. So now what will be RTH? If two resistances are connected in parallel, we can directly, I mean, keeping this 1 by R1 plus 1 by R2 is 1 by R equivalent, right? Simplifying this, what do we get? R1 R2 upon R1 plus R2, that is 12 multiplied by 12 upon 12 plus 12, and this probably comes out, I might have the answer. So yeah, so this is 6 ohm. I have solved it already. So this RTH comes out to be 6 ohm. Okay, so now you can draw the equivalent, the third step, the remaining third step. I forgot to write here. So this is step 1, find the value of ISC. Second step is find the value of RTH. And the third step is draw Norton equivalent circuit and find I, right? So we'll come back here, we'll draw Norton equivalent here. So Norton equivalent, you know that this is ISC, this is RN, and this is that resistance R, right? So ISC, the value of ISC is, we'll quickly check it. ISC is 8 ampere, Rn is 6 ohm, and where you need to find the value, that is also 6 ohm. And you need to find the value of current here. So I is equal to, applying current divider, 8 multiplied by 6 plus 6, right? So 8 into 6 by 12. So final I comes out to be 4 ampere, right? So this was the way to find the value of the current in across 6 ohm. Okay, so thank you.